Welcome to Part 10 of our Competency 17 practice. In this video, we will solve problems relating to null hypothesis and alternative hypothesis. On the TI-84, this will be your Z-test or your T-test. Okay, before we begin, we just want to remind you about some of these key terms. The first term is the null hypothesis. That is simply I refer to that as the mean that we begin with. And then you have the alternative, and that's going to be what you think it's going to change to and how those changes are within the wording in your problem. Okay, then your level of significance, that is your percentage they give you in the problem. It's so you know how to measure if you are to reject or accept. We'll talk more about that as we go along. Okay. Then we want to talk about what we're really going to be doing on the TI-84. We are going to be using the Z-test and the T-test. Now, the actual types of testing are listed, and you have your two-tail, one-tail. We will explain this some as we go. If you don't understand or really don't remember this, I recommend that you go to all of those vast resources on the internet. There are great videos and some really great people out there that do a fabulous job of explaining these things. My purpose is in this video and all our videos is simply the TI-84 use so you can pass the test as quickly and efficiently as possible. Okay, so that being said, let's do number one. Let's get this over just a smidge. Okay, number one. Among all of the homeowners in Dallas County, a researcher has claimed that the average age of homes was 19 years. Okay. All right. A current study of 50 homes reveals an average of 21 years. This is our N, 50, with a standard deviation of 2 years. At the 10% level of significance, what decision should be made concerning the researcher's claim? Okay, the first thing we need to do is to decide, are we using a Z-test or a T-test? Well, just as some of our elements that we did in prior videos, doing our intervals, that 50, that's our N, and it's greater than 30. If it's greater than 30, we go with the Z-test. So we will be using the Z-test. So that is stat, and it above here, below there, stat over, right below the image. See, that's what I'm doing right here. Okay, then we don't have to push any numbers. We just enter. Now, the difference between data and stats. Data, you've got to put information into the TI-84. In your L1, your L2, we are not using data. We are using stats. So because we're using stats, we just take the numbers out of our word problem and put them right in. So let's clear that out. So our mu naught means original. Okay. If you know anything about mathematics, as far as going on past just your first few years in college, you know that you have a starting is your naught, that little index of 0. So our starting value is our claim of 19. They're saying, hey, this is our start. But now the rest of this is our new information. So that new information, a current study, we have a deviation of 2. Now we have a new mean. Well, they're saying, hey, it's 21. It's different. Okay. Now our N, our sample size is 50. Okay. Now we need to decide, are we going to select A, that it's the same, or are we going to go with A, less than or greater than? See where we're flashing there? You can arrow over on those to make the selections. Let's go to our word problem. Our word problem makes no claim of less or more. Because of that, we will go with what's flashing there. You enter and it keeps it. Okay. Now, enter down. Now, this coloring of light blue, we'll get to that on other questions. Yes, you can change it back and forth. Now, we're not drawing, we are calculating. So that's our p-value. Okay, make note that sometimes your p-value is going to be in a scientific notation. Let's go to our answers. Well, they were nice. At least they gave us the scientific notation and they didn't try to type all of it out. Okay, well, we can eliminate C, and D. They're gone. Now, are we going to accept? And we're going to talk about this wording. Right now, we're going to use accept. Definitely always reject is used. So are we going to do one or the other? Okay, in this situation, we see that our p-value over there, okay, we see that p right here is this guy right here. Is he less than or greater than the percentage given in the problem? He is less than, okay, less than the percentage in the problem. Okay, because he is less than, we pick B. Okay, so let me get rid of this so we don't confuse what we're saying. This is what we are accepting. Oh, sorry about that. Okay. Now, I need to explain why. What this says is that the probability that we get 21, the new average, as the mean, the true mean, is less than 10% when the mean of 19 is actually true. Thus, the new claim of 21 is rejected when our p-value is less than the given percent. That's a rejection. Okay? We do not want the new claim, or we do not stay with the claim, or we don't accept whatever the claim is saying. We reject it. We go with what we have. Okay? That will be our answer. And we're not going to draw right now. We'll get to that in the next problems. Number 2. It has been established that the time required for math professors to grade a student's final exam is normally distributed. A well-known educator claims that the mean time for the distribution is 10.5 minutes. A current study involving 15 mathematics professors at a local college showed that the mean time was 10.1 minutes with a standard deviation of 0.7 minutes. At the 2% level of significance, what decision should be made concerning the educator's claim? Okay, well, for this one, they're not making, we go back to your original here, this 10, when you go to, it says a well-known educator, and then your question asks about the educator's claim. Notice there is no less than, greater than. They're just saying, hey, this is what it is. So that means we're going to use a comparison of equal to or mu naught. Okay. So we push that over, and our sample size is 15, so that implies a t-test. In our original, mu naught is 10.5. And then our new claim, our new study is 10.1. And then our standard deviation is 0.7. Notice how it's self-corrected in the calculator, what it wants, okay? So now we have our 15, our size, and we need, see how it's flashing, and we had an old comparison? This is our claim that we're testing, because there's no other words in our word problem that say otherwise. We go down, we'll do that later. Okay, we're just calculating right now. And okay, so that's our p-value. From that, we know we can get rid of A and we can get rid of C. Okay, now, is our p-value less than or greater than our percentage? So our given percentage is 0.02. Our p-value is obviously less, which is 0.044. That's our p. Remember, you're measuring it off the p given on your calculator. If I could write better. Oh, it's on our calculator. We see it. Okay, that means we need to reject. And if you compare your p-values, your two questions, your B and your D, look down here at the end, and it says must be rejected. That's what we want. Notice in D, we don't want it. It says not rejected. That's the same as accepting in scientists' terms of being safe. We don't want that. We want to actually reject because of our p-value. Okay. Number 3, among all hospitals in Oklahoma. Oh, I am so sorry. Let me go back and draw that. I almost didn't do that for you. Okay, go ahead and do stat again. And yes, I will have to go all the way down. There's no way to do it otherwise. I have it on the light blue. You can change that look. You can change it around. Oh, let's just do yellow. Let's change things up. And then we go down. You have to arrow over and enter. Let's see what it gives us. A two-tailed test, which matches with the fact that we were using the not equal to comparison. That also tells you not that when you're doing the not equal to, it is a two-tailed test, which you may be asked on the state certification test or on a practice test for the certification at your university. So now you know how to get that answer really quick. If you know what to do in this problem and you study and you watch the videos, then you know, oh, I know where to go that's my calculator cheating. Okay, it's not cheating, but it's very helpful, very convenient. Okay, now let's go to number 3. Among all hospitals in Oklahoma, a state health official has claimed that the average noise level is at least 60 decibels. Okay, there's our claim. A recent study of 40 hospitals shows the mean noise level of 59 decibels with a standard deviation of 4 decibels at the 5% level of significance. What decision should be made concerning the health official's claim? Okay, we have a z-test because 40 is greater than 30. Okay, and we have a good sized population. Okay, so we need to find out what our P equals. All right, so let's get out of this. Second mode to get out of stuff. You should know that by now, but just in case. Okay, stat over. We're just doing the Z, so we enter. Still doing statistics. Okay, our original claim value is 60. Then our deviation is 4. Oh, I already have that typed in. And our new claim is a 59. And then our population size is 40. Now, we are not using equal anymore. We need to go to one side or the other. It says at least equal to 60. So this means that they're trying to say 59 is less than your original. That number is less. So we need to go over to the less. We're saying, hey, our new value is less than what we had before. Enter. Now you'll have to arrow down. And I'm not drawing yet, so I'm not going to worry about that. I'm going to calculate. Okay, there is our new p-value, and we have a rounding situation. So that means A and B are out. Now, our p-value, let's see here. It is 0.057. And is that less than or greater than 5%? It's a little bit greater. This means we cannot reject. We cannot reject. And see where it says must reject? Okay. We aren't necessarily accepting it. You know, these words, you may see them, but it's not industry standard. But that means for these questions or this test question, you select D. Okay. I know that's annoying, but they do that. It's just the wording. It's uncomfortable. Okay. Number 4. Oh, I almost did this. Let's go back and draw it. Can you believe I didn't do that? Okay. You got to draw it because I got to make my point. You got to see this. Go all the way down. Okay. Now I'm going to go back with, all right, let's find a new color. See all these great colors I have? Hot magenta. I call hot pink. Whatever. Okay, let's draw it. Let's do this. Here we go. And what does it tell you? We selected the not equal to, right? We had not equal to mu not. Okay, that implies that you have a left tail test. And if you can't remember the rules, but you know you remember how to answer the question, then okay, go answer the question, then go back and draw it real quick. And there you go. There's your answer. Nice. Okay, let's exit out of that. Let's go to number 4 now. Long, I believe that should say along. Typo, instant correction, sort of. Okay. Along an interstate. Oh, lovely. I hit something. Along Interstate 35, many motorists seem to obey the posted speed limit. A Department of Transportation official has claimed that the average speed is no greater than 62 miles per hour. A recent study of a random sample of 25 vehicles that used this interstate revealed that their average speed was actually 65 miles per hour with a standard deviation of 2.5 miles per hour. Assuming the average speed is normally distributed and a 1% level of significance. Oh, and I added this in also. So you could see if it's an alpha comparison. Okay. This is used some in textbooks and various places, just in case. Okay, what decision should be made concerning the Department of Transportation's official claim? Okay, this official claim is they're saying, hey, has claim. They're saying these guys, everybody only goes 62. Come on, who goes 62 out on 35? Have you been on 35? I've been on every part of 35 of this entire state. This question always makes me laugh. Okay, moving on, moving on. Okay. All right, we're going to go stat over. And what kind of test? We need a T test because we only have 25 cars. Okay. I think that's why they're making their claim there. Okay, let's do two. We have our stat chosen. All right, let's go to our original is 62. I'll believe it for a second. They did that during traffic, bad traffic. Okay, and our new is going to be 65. Okay, now our standard deviation is 2.5. Okay, our sample size is small, 25. Okay, what is our claim? They're saying that it is going to be greater. So we need to move over. Okay, our mu. Oh, no, wait a minute. No, we don't. Let's see. 62 is less. So we're still making the same one. Let me read it again, make sure. Okay, yes, it is the same claim. If you think about it, let's look at this. At least is at least equal to 60. So they're saying everything was that their mu is above. Wait a minute. So no, we have the opposite situation. Okay. All right. No, that's their claim. Our claim is the other one. Okay. All right. I'm sorry. I shouldn't say their and our. Okay. So is no greater than 62. Okay. So they're saying that their new claim is greater. Okay. Let's go over and enter. Let's calculate. Okay, yeah, we've got a valid answer. Okay. So now that I've confused you thoroughly, you can go back, stop the video, ignore me, look at it carefully yourself. Because what's really going on is underneath the curve. Okay, it says the average speed is no greater. They're saying everybody drives uh, at a lesser speed, I suppose. So they're trying to look and say, well, all my speeds are over here and it's not going to go above. But then the new study says, hey, no, we see a speed that's greater than that. So let's test this level of significance. Let's see if there's any reason to have a new test. Okay. Now, we've got we can get rid of C, we can get rid of D. But what's going on here? Okay. Actually, if you look at B, these two guys are exactly the same. My calculator is giving the estimate because it says approximately. That's the value for A. But if you go and count over from here, you're going to count over 6. So that's just your scientific notation versus written out. They're the same thing. So we still have to decide which one's which. So don't automatically choose A. Take a look. Okay, so what do we have? Well, this is our measure. So our p-value, our p which is both these right here, is going to be significantly less than the given. So this tells us, remember, if it's less, we must reject that claim. So we want B for number 4. Okay, before we move on, we want to draw this. Okay, and which side should that be on? Is it the right-tailed or left-tailed? Do you remember? Well, let's look again. Okay. And what kind of test did we have? Yeah, that was 2. Okay. I didn't want to select the wrong thing. Okay, so we should have the other side. It should be right. And I have a note here saying what to pick. So let's change the color. Just because. I mean, you can do whatever you want. Let's do the light blue I had in the first place. Okay. Oh goodness, you can't even see it. Now I wonder why that is. I'll tell you why that is. It's because it's such a very tiny number. Go and compare what we have here. Look, it's 0.00000, and these p-values, they weren't as tiny. That is very tiny. If you look at your calculator and put it, I mean, I could zoom in. I mean, I've tried. Even zooming in, you can't see. But if you do it on your calculator, you'll see a tiny little bit over on the right that'll show it to you. So in some cases, it isn't helpful. You actually need to know the difference between these tests. Okay, hopefully if you're asked that question, it's a large enough number that you can just go draw it and figure it out. Okay, let's move on. Now we're going to introduce the inverse norm on our TI 84. Okay. Number 5, among a certain population of 157 men, the mean systolic blood pressure was 146 mmHg. Not sure what that means, to be honest with you, but you can go look it up, with a standard deviation of 27. We wish to know if, on the basis of these data, we may conclude that the mean systolic blood pressure for this certain population is greater than 40. Assuming the mean systolic blood pressure is normally distributed and a 1% level of significance, there's your alpha score, what decision should be made? Okay, let's decide. Okay, our population is pretty large, so this, we can assume from this, I'll just go ahead and circle it, that we have a Z test. Okay. All right, so alpha over, enter. All right, so our first mean, now this is confusing. They actually are introducing the new study first, or an original, a first study being the new study. I'm not sure how it's, what's behind this information. However, we see that they're trying to see if for this, that the claim, so with the claim greater than 140, because of that, that is our mu naught. Okay, so that means that we put 140 in first because it's with our claim. That's how I rationalize it when I'm just trying to take a test. There's more to this explanation. You can do that on your own. Okay, now we have a standard deviation in the actual study. This is the study itself. That's 27. Now, from that study, they're saying they have a mean of 146. And the actual amount of people in the study is 157. Okay, now we are going to measure that greater than 140. So in our calculator, we need to think about this. That means that we need to say, they're saying that from our study, that it's actually greater. So we go over here where it's blinking, we're going to use that again. Because what they're saying is the study above that mean is truly greater than your mu naught. Okay? All right, let's arrow down and enter. Okay. And we get a p-value of 0.0026. Okay. That won't work. That won't work. That isn't going to work. Looks like they rounded. Okay, great. Well, from that, to me, it looks like that's going to be the answer. But just in case we entered things wrong, make sure, or we're looking at things wrong, make sure that it matches the rejection or accepting. I say we're correct. Okay, so our P, okay, we've got 1% here. Our P equals 0.003. Is that, remember, if we reject, it says reject. If we reject, it must be less than. Is it less than? Yes. Definitely less than. Okay. So we know that C is our option. Okay, moving on. Let's talk more about the z-score itself and the one-tailed and the two-tailed and how this would really look. Remember when we tried to draw it before, that we just didn't get a good drawing out of our calculator. We can go back for this problem and go see what we get. Okay. You can barely see and we see what our z-score is. See it there in the corner? You can see a little bit darker over here on this side. That's not enough to make a visual decision with the calculator when you're testing. Okay, but make a note of your z-score. Oh, looks like they have the z-score here. Okay, yeah. Well, let's go ahead and write it. That's funny. Okay, so let's 2.7844. Okay. So now we've made a note of what our z-score is. We've drawn it. We can see it's not too helpful to the human eye. So, but because our z-score is positive, it's positive. We know that over here, somewhere on the right-hand side, we know that we need a right-hand side. And we know that also from what we put in our calculator. So we need to select this. Now, let's go do our inverse norm. Let me explain to you where I'm going with this. Okay. So that second bars, okay, and inverse norm, as you can see, is number 3. Okay. Now, what we want is to go back to this alpha. We want this significance level. We want 0.01. Put that in your calculator and you're going to enter. Leave the 0, mean, and the standard deviation of 1. Why am I saying that? Because we're using a normal distribution and a z-score, and we want to compare and draw out and explain our rejection zone. We are creating the actual rejection zone that we couldn't see in our calculator. So I'm going to go for right-tailed test because that's what we actually entered in the calculator. Enter. Oh, I'll have to arrow down. Okay. That gives us the comparison z-score. Comparison z-score. Okay, so let me draw that in. Remember, we're comparing this. Where would that be? Well, there's our 2.5. Uh-oh, looks like my picture moved a little. It actually should be over a little. I'm not sure how that happened, but it happened there. Looks like some things needed adjusting. Okay, so where should that be? Somewhere in here, right in here, we'll have 2 point, we're going to round to 3, 3. 3, 3. That is the Z, okay, roughly. Now let's highlight in. I'm going to pick this. Okay, and a very tiny little drawing. So that means this little bit right here, that's our rejection zone. Reject. That's our zone of rejection. Where was our true z-score? Okay, I don't know that it matters if I change to something brighter or not. Our true score was 2 point, say, okay, was somewhere over here, closer to 3. Okay, so it was 2.78. So obviously, our z-score is in the rejection zone, and that verifies that our p is less than our level of significance. And see, this is the z-score that we imply by that alpha equaling 0.01. So we're within the rejection zone. Okay, that's our last question and our final explanation for this video. Thank you so much for watching and being forgiving and patient with my explanations. I truly hope they're successful, and good luck on this portion in any of your testing. If you like us, think about subscribing and giving a thumbs up for this video. Thank you again.